All right, so in AA1-8, calling it part 1, but I don't think we're going to have part 2. We'll just move on to 1.9. We're going to be reviewing / reteaching multiplying and factoring quadratics. So the first thing we did in the warm-up was to factor the following numbers. Easiest way to do that, in my personal opinion, is to start with 1 and the number. So you take 90 divided by 1, which gives you 90. It's always going to be 1 in the number. And 90 divided by 2, which gives you 45. 90 divided by 3 gives you 30. 90 divided by 4 is not a whole number, so we're not going to list it here. 90 divided by 5 is 18. 90 divided by 6 is 15. 90 divided by 7 is not a whole number. 8 also not a whole number, and then we're to 9, which is 10. And then if we keep going on to 10, we end up with 9. And that right there is how we know we have all of our factors, because the numbers either switch, they have no space between them. So once we duplicate our pair of factors, we know we have them all. 24, 1 and 24. 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 4 is 6. 24 divided by 5 is not a whole number, so 24 divided by 6 is back to 4. So we're done with that one. 1 and 150. 2 and 75. 3 and 50. It's not divisible by 4. 5 and 30. It's not divisible by, oh yes it is. 6 and 25. Not divisible by 7. Not divisible by 8. Not divisible by 9. So then we're at 10 and 15. Not divisible by 11, 12, 13, or 14, and then we're back to 15 and 10. So that is the easiest way I find to list all of your factors, particularly with what we're going to be doing in this section. So first off, just to review, multiplying a monomial by a binomial. First we multiply 2x by 3x, and that involves multiplying 2 by 3, which gives us 6, and then x times x, which is x squared. And then we multiply 2x by 5, which means we multiply the 2 by the 5 and keep the x with it. So this uses the distributive property, and this gives us a partial quadratic. Factoring partial quadratics is just the opposite of distributive, greatest common factor. So it's called GCF factoring in some cases, for some people anyway. So what you need to look at first when you're doing this factoring is take 10 and 4 and see what their greatest common factor is. They're both divisible by 2. There's nothing else because 10 isn't divisible by 4. So we're going to take that 2 and put it out front. And we're also going to take out, because we have an x squared and an x, we can also divide by an x. So we're basically taking a 2x out from both of those and figuring out what we have to multiply by. So 2x, we have to figure out what we have to multiply 2x by to get 10x squared. So you can also look at that as 10x squared divided by 2x. And if we did that, we would get 5x. Get rid of that. 4x, so to multiply, to get 4x, we have to multiply 2x by 2. The other way you can look at that is, what is 4x divided by 2x? The x's divide out, and 4 divided by 2 is 2. So this is our factored form. Basically undistributing. So to practice, you might want to... Okay. So 12x squared minus 9x, we need to figure out what the greatest common factor of 12 and 9 is. The biggest number you can divide both of those by is 3, so we take a 3 out front. They both have x's with them, so we take out a 3x. So we can look at it this way. 12 divided by 3 is 4. X squared divided by x is x. And then 9 divided by 3 is 3. And that's our factored form. So that was the undistribution there. 8 and 22, greatest common factor is 2. Because this is a negative, I'm going to go ahead and take out a negative 2 and then also take out an x. The reason I want a negative out in front is because whether I'm in factored form or standard form, if I know my a value, my leading coefficient, if I know that's negative, I know my entire graph is going to be flipped over, so this parabola would be facing down. So to get negative 8 squared, we multiply this by 4x, pardon me, and then 22x divided by negative 2x is going to be, negative 11, and that's our factored form on that one. Okay. So going from standard form to factored form, just kidding, wow, going from factored form to standard form, this right here is the factored form because we are multiplying two factors. 2x plus 3 is one factor, x minus 4 is the other factor. So that's factored form. To get it into standard form, one method is to use the box method where you take one factor on the outside, 2x plus 3, and then x minus 4 on the other side, and then we multiply basically our rows by our columns. So 2x times x here, 2x times negative 4 here, 3 times negative 4 goes here, 3 times x goes here. So, there we go, oops. 2x times x is 2x squared. 2x times negative 4 is negative 8x. X times 3 is 3x. And negative 4 times 3 is negative 12. So, the important thing with using the box method that a lot of people forget is that you have to write out what's inside the box. So you've got 2x squared minus 8x plus 3x minus 12. Combine our like terms. So we've got 2x squared minus 5x, that's a negative in case that's not obvious, and then minus 12. So that right there is called standard form. FOIL method is first, outside, inside, and last. That's what those letters stand for. Except I wrote the O twice. Don't worry about it. So 2x plus 3 times x minus 4. Mathematically, this is the exact same thing as the box method. It's just a different way of looking at it. So we multiply our first terms, so 2x times x, which is 2x squared. Multiply our outside terms, so this is the f, this is the o. 2x times negative 4 is negative 8x. Inside terms, 3 times x plus 3x. And last terms, 3 times negative 4, which is negative 12. So 2x squared minus 5x, again, combine your like terms, minus 12. So we end up with the same thing, just the process looks a little different, and it just depends on what works best for you. I really don't have a preference. Okay, so factoring can be done with algebraic grouping, or it can be done with the box and diamond, which is what most people have become more accustomed to. There's a shortcut when a equals 1, meaning we don't have a number in this position. So like over here, it's just x squared. Here it's 3x squared. So this is where a is not 1. This is where a is 1. I'm going to show you the exact same process on both. If you know the shortcut and you figure out the shortcut, then by all means use it. But generally speaking, I find that when I teach the shortcut for people who have trouble with this particular process, it doesn't do them any good. So I'm just going to show you the same process for both. So you start with your first term, x squared, and your last term, 40. I'm going to take those and I'm going to multiply them. So I get 40x squared. I'm going to take my middle term, 13x. I'm going to put it down here. So then what I need is two numbers that multiply to give me the top and add to give me the bottom. So I need my factors of 40. We got 1 and 40, 2 and 20. This is why we did this in the warm-up. Not divisible by 3, so now 4 and 10. 5 and 8. Not divisible by 6 or 7, so we're back to 8 and 5. They're both positive, so everything's going to be positive. So my pair that adds up to 13 would be 5 and 8. So 5x and 8x. So I put those in the remaining boxes. Doesn't matter which goes where. And then I'm going to factor out from each row and column, or sorry, row and column would be more accurate. So what I can take out here, 5x and x squared are both just divisible by x. And then I can build it around that. So x times x gives me x squared, x times 5 gives me 5x, x times 8 gives me 8x. And then I always want to double check that this number and this number multiply to give me this. So 5 times 8 gives me 40, so I'm good to go. Then I need to write it in factored form, which is x plus 5 times x plus 8. That is my factored form. The process is the same, but you need to be more careful when you factor when a does not equal 1. So again, I make my little diamond and box there. Yes, I know it's an X. We say diamond because we used to put like a little diamond around that X, and it's just annoying to do that. So anyway, tangent. Same process here. So first term, 3x squared. Last term is 8. Multiply those. 3 times 8 is 24. So x squared. Our middle term is negative 14x. Make sure that you note that if that is negative, or if anything's negative, that gets accounted for. So then I need my factors of 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. If I have a positive number on top, I know that a positive times a positive equals a positive, and a negative times a negative equals a negative. So if this number is positive and this number is negative, that means that both of my side numbers are going to be negative numbers. So the pair that adds up to negative 14, negative 2x, and negative 12x. And those go in the boxes. And this is where you have to be careful. So back over here on our original, these two numbers were exactly the same because x times 5 gave us 5x, x times 8 gave us 8x. Over here, that's not going to be the case because I need two things to multiply to give me 3x squared. So one of them is going to be x and one of them is going to be 3x. So I can't take the 3x out of this row because negative 2 is not divisible by 3. It has to come out here. So that 3x is going to come out here. I multiply 3x by x to get 3x squared. And I multiply 3x by negative 4 to get negative 12x squared. Multiply x by negative 2 to get negative 2x. And then I always want to double check. Does this term, negative 2 times negative 4, give me positive 8? And yes, it does. So my factored form here, 3x minus 2 times x minus 4. Right, so practice here, multiplying out. I would pause this, by the way, and attempt this practice on your own. That'd be a better idea for you. If you just watch me go through all of it and you don't practice any of it, try it on your own and you're not going to do quite as well. Okay, it's 2x times x, 2x squared, 2x times 6, negative 12x, 4 times x, plus 4x, 4 times negative 6, minus 24. So 2x squared combine like terms, minus 8x minus 24. So that's my standard form. Next one's in standard form. I'm going to do it in factored form. So, yeah, I'll do box and diamond again. I actually personally prefer the algebraic grouping, but most people haven't done it that way. So I'm not going to worry about it. And this process over here is kind of redundant with this one, but that's up to you. I'm going to go ahead and keep showing it. 1 and 15, not divisible by 2, and then 35. When the top is negative, that means one of our side numbers is going to be negative. If the bottom is positive, that means our smaller number has to be the negative one because they have to add up to be a positive. So, negative 3x, pardon me, 5x is the pair that works. So x 5, negative 3, and negative 3 times 5 is negative 15. So my factored form is x minus 3 times x plus 5. And that's that. Okay. So we have another set here that is called difference of squares. So something that happens when you multiply these out is you end up with x squared minus 8x plus 8x minus 64. Positive and a negative of the same term give us 0. So these two add out to 0. So we've got x squared minus 64. Same thing here, we've got a plus and the minus of the same thing. So this is going to be 4x squared minus 10x plus 10x minus 25. Negative 10x plus 10x add out to 0. So 4x squared minus 25. So we have this pattern wherein if we have the same first term and second term, but we have a different sign, this is what's called a difference of squares. This one's going to be x squared minus 100 because we know the negative 10x and the positive 10x in the middle are going to add up. So because we know this pattern, we can also use it in the opposite direction to factor. If you don't want to use, if you don't notice the pattern, you can always use the box and diamond method. Like this middle one could be written as x squared plus 0x minus 25. So you can use that and still do the same thing. It's just going to take you longer. So if you can see the pattern, that's going to be to your advantage. So if the first term and the last term, and there are only 2 terms, and they have to be subtracted, have to be. If they're not subtracted, then we have an imaginary number situation coming into play, and we're not going to do that until later. So if the first and the last term are what are called perfect squares, 2 things multiply together to give us that, then we can factor this using difference of squares. The square root of 4x squared is 2x. And the square root of 9 is 3. Make one a plus, one a minus, and that's that. Square root of x squared is x. Square root of 25 is 5. So x plus 5, x minus 5. This one, I don't like how this is written. I just couldn't type it any other way. 1/9. The square root of 1/9 is 1/3. Because 1/3 times 1/3 equals 1/9. The other way to look at that is the square root of 1/9 equals the square root of 1 over the square root of 9. So 1 over 3. Let's get that out of the way. So, there we go. That means we've got 1/3 x, and then the square root of 64 is 8. So plus 8, 1/3 x minus 8. So if you can recognize that it's a difference of squares, these first 2 would be easy enough to do with box and diamond. This one would be way more complicated because of that 1/9. So if you can recognize that pattern, that's definitely to your advantage. means, ooh, I don't know what just happened. All right, now, this one is one of the most frustrating things that a lot of people do. So if I have x plus 8 squared, a lot of people do x squared plus 64. So if that's what you thought it was, I want to check this. I want to go ahead and check it with a number. So let's say x equals 2. So in this case, that would be 2 plus 8 squared, which would give me 10 squared, which would give me 100. In the second case, so in this part, if these are equivalent statements, that would be 2 squared plus 64, which would be 4 plus 64, which would be 68. Those two are not equal. So this is not correct. You cannot distribute a square into parentheses if you're adding or subtracting anywhere in those parentheses. So I'm going to erase a whole bunch of stuff here. All right. So what it means to square something is that you are multiplying it by itself, which means we are taking x plus 8 and we are multiplying it by x plus 8. And x times x gives me x squared. X times 8 gives me 8x. X times 8, or 8 times x, sorry, is 8x. And 8 times 8 is 64. So combine your like terms. So we've got x squared plus 16x plus 64. This is called a perfect square trinomial. And this is important when we get into completing the square, which is going to be the next class. So it's important that you recognize you have to multiply those things out. You end up with a middle term. So on the next one, 2x minus 4 times 2x minus 4. And some people will start to see the patterns here, and that's fine. 4x squared minus 8x minus 8x plus 16. So 4x squared minus 16x plus 16. That's our perfect square trinomial. Last one, 3x plus 5 times 3x plus 5. 9x squared plus 15x, and then plus 15x plus 25. Combine our like terms, we get 9x squared plus 30x plus 25. Okay, so once again, if I have a plus b squared, that does not equal a squared plus b squared. So keep that in mind as we move into the next thing. Make sure you understand that when you square something, you are multiplying it by itself. So that is it for that lesson. Hopefully review for a lot of you, but if not, hopefully you're a little bit more comfortable with it now. And have a lovely day.